introduction and thank you for inviting me here. All right. Yeah. So I lied. Well, I'm just going to show you 10 minutes of fantastic beasts as a preview. So this is just a clickbait. I'm kidding. We're here to talk about data science beasts and where to find them. Hopefully you got the reference. But before we begin, 97 zettabytes, and 1 zettabyte is 1 trillion gigabyte. So 97 zettabytes of data was produced in the year 2022. Out of that, how much percentage do you think is actually being used to deliver business outcomes? 1%? So pessimistic. Anyone a little more optimistic? 40%? To 60%, a little too optimistic. The correct answer is 20%. And if this statistic scares you, it really should, because it should scare you. It does scare me. So why this talk? Honestly, the field of data science has so much hinging on trial and error, but we don't really talk about our failures openly, right? I want to use this talk as an example to say that failure is not a personal flaw. I want to destigmatize failure, and hopefully we can all talk about our failures and learn collectively from each of those. Because let's face it, nobody has every project be successful, right? All right, so the first point of failure with a data science project is, of course, data. No explanation over there. Sometimes I joke that I shouldn't be called a data scientist. I should be called a data scientist, because I look at the data and I just keep sighing that it's in Excel spreadsheets or in really weird, terrible formats. Oftentimes executives come up and say, we want a data science AI model. Okay, where's the data? We are not collecting any data. So data maturity can be one way that the data beast attacks you. Clean and complete data. There was a case study where this person was trying to create a machine learning model to predict loan applications. And turns out after this model with great accuracy and perfect scores was implemented, the rate of delinquency, that is the loans defaulting, increased marginally. Turns out the model was trained on data for approved loan applications and not for every single application. So that was an issue over there. You need to ensure that data is standardized and relevant. There's the concept of Frankenstein data sets, which means that you might have data sources coming in from multiple streams, and because of that, you might have duplicate data. And if you don't remove those duplicates, you would have that in your training as well as your testing set, which means you will wrongly think that the accuracy of your models is higher, but that's actually not the case. And of course, whoops, you are getting a spoiler alert. All right, we'll just pretend this didn't happen. Biased data. So funnily enough, they were trying to train this AI model to see if they could detect which hospitals had a lot of case loads. And the AI ended up predicting the feature of the text of the labels for the hospital case files, and saying that, hey, if it's coming in a bold font, that's actually a predictor of it being high disease, which doesn't really make sense, right? The second beast that can attack us, or that can make our data science project go wrong, is infrastructure. So let's see. You don't have access to a standardized infrastructure. Often the case with a lot of things that we see in real world, because everyone has different formats, different systems. You don't have robust architecture. What happened in the pandemic with the UK government was that they were using Excel spreadsheets to record all the COVID data and the contact tracing data. And of course, Excel has a particular limit, it's not endless. And they hit that limit, and because of that, in October of that year, 16,000 cases went unreported because they thought they were entering it in the Excel file, but the Excel file just terminated the data. Yikes. Silos in data and gatekeeping, again, not something that's very new. Everyone wants to come up with their own format, with their own infrastructure, with their own data system. So having a decentralized architecture in this case is actually not a good thing. And finally, vendor lock-in. I like to call this as Hotel California. I have faced this personally. You go with a vendor, they hold your data hostage, and then they say, give us $1 million and then we'll release your data. True story. The third beast we're going to see is implementation. So with implementation, make sure that you're prototyping and scaling with real data. Also had this unfortunate experience where we spent a lot of time and developer resources building a project, only to realize that we, at the end of the day, had maybe 100 good data points and we were expecting at least 1,000 plus. So not a good use of our time. Cost benefit analysis. Anyone here familiar with the Netflix $1 million prize project? So a few years back, Netflix had this competition which said, hey, we're going to award $1 million to anybody that can make a better recommender than what we have in place. And a team won, and they got the $1 million, but Netflix never implemented that solution because implementing that solution would actually cost them much more than $1 million. So they just said, hey, screw it, the increase in accuracy is really not worth it, we're going to stick with our current solution. So make sure it's actually cost effective to implement the data science model. Ethics, we are in the era of ChatGPT, generative AI, a lot of things are going wrong. This I think is definitely something that we need to pay more attention to. And last but not the least, maintenance, especially in a changing climate, right? Where, let's say today you start off with certain data privacy rules and regulations, maybe a year or 2 years down the line, it changes, right? Constantly evolving information. How do we make sure that our models are accounting for all of that drift? Last but definitely not the least, culture, and a really, really big one. I think one misconception that a lot of the leadership, a lot of executives still have is that data science is very similar to software development. That's actually not the case. You cannot use traditional agile methods for data science. Data science is indeterministic, experimental, exploratory. I cannot come in and say, hey, you have 3 months, give me something, and nope, maybe the result is inconclusive, and that's completely valid, right? So it's not very deterministic. And once you change a small parameter, a small part of the pipeline, you might actually end up changing everything because everything is so interdependent. Make sure that your models are providing business value. There's a statistic that says only 44% of the data science teams are actually providing a business value. Ensure you have multidisciplinary teams. You need investment in the right tools. And of course, communication and alignment with your stakeholders, with your investors, with your executives is extremely important. Yes, the past can hurt, to quote Lion King, but you can learn and you can run. You can run away from it, but you can learn from it as well. So how do we control these beasts? Make sure that the data you have is standardized, is clean, is free from biases, you're getting rid of duplicates, and leverage what's known as a data contract, a sort of a document that tells the data owners, hey, this is the kind of contract we're agreeing upon, this is the data set, this is the format. So make sure you have that in place and adhere to it. What happens if something goes wrong? Robust infrastructure is, of course, essential. We talked a little bit about that. Make sure your data vendors actually have APIs, so you are not in that Hotel California situation. Consider a centralized architecture where appropriate, but make sure that there is thorough documentation of the data owners at all particular times. And this leads us into ensuring that there's strong data governance across the company. With implementation, make sure you are using it ethically and doing a cost-benefit analysis. You don't want to end up like Netflix in that case. Monitor after deployment and understand if this is a prototype or something that's going to go in production. With culture, ensure that you have business value, that your stakeholders have the right expectations, get buy-in, get sponsorship, and do a pre-mortem. Try to, even before you begin the project, understand what can go wrong. Whoops. Try to understand what can go wrong with the project, right? Imagine 6 months down the line, your project has been an absolute failure. Come up with a list of things for why that happened. Was it culture? Was it implementation? Was it data? Was it skills? So that's the pre-mortem that I would strongly advise you to do. Here's a list of resources that I will share a screenshot of later. But honestly, courage allows you to learn from your failures so that in the end, you haven't actually failed. Be not just the data scientist who lived, be the data scientist who thrived. And hopefully with these suggestions and me sharing my experiences, you'll be on your way to do that. Those who cannot remember the past are doomed to repeat it, or are probably data science models with low IQs. So this is it from me. This QR code will take you to the list of resources, and I welcome any feedback or any questions that you might have. Thank you so much. I guess we have time maybe for a question.
Maybe one.
All right. If there are any questions, I welcome them. All right, perfect. So we're all going to start talking about our failures from data science. I encourage you to do that throughout the rest of the day. And of course, if you have any questions, any thoughts, any feedback, I'm here all day. Please reach out to me. Thank you so much again for inviting me.
Thank you, Grishma. Thank you.